Hello and welcome to this tech talk today about k0smotron and Cluster API with the title Expanding Horizons, k0smotron's Integration with Cluster API and Beyond. For everyone who's not familiar with k0smotron, there was a part 1 tech talk that you can watch too. That's available on YouTube, or you can just browse mirantis.com/Mirantis Labs or Labs, only Labs. And have a look for the part 1, but I will give you a short introduction to k0smotron as well. First of all, you're seeing or hearing myself, Julian Hennig. You can reach out to me by email. You can have a look for all contributions on GitHub. I'm contributing a lot to k0smotron and k0s at the moment. There's different links you can have a look to, and of course, feel free to connect on LinkedIn. We'll go into a short introduction of k0smotron, into what is Cluster API, a bit more into the details about Cluster API, what is it, and how does k0smotron and Cluster API work together. As well, we will have a look into how you can create a cluster with k0smotron and Cluster API and deploy it to any environment. And we'll also have a look into an example and a demo. So let's start with k0smotron, something that we've already introduced. I think it's already 3 weeks or more, a month ago, in a tech talk. k0smotron is a Kubernetes control plane manager. So a service you can install to your Kubernetes cluster, to any Kubernetes cluster, and create k0s control planes. So the main feature, as mentioned, is control plane as a service. We basically focus on k0s control planes. With k0s itself already, you have enhanced high availability features. So the cluster state store does not need to be etcd. With Kind, you can use any SQL, MySQL. You can even use other managed databases for that as well. So a lot of different options. And we have something that's called bring your own worker nodes. So the bring your own worker nodes gives us the ability to integrate with Cluster API. So the worker nodes can sit wherever you want to run your worker or your workloads. With k0smotron, you have a reduced footprint just because of the architecture. With k0smotron, you have like all the control plane functionality sitting inside of the management cluster of one cluster that can run in an, let's say, cheap environment. And you have consistency across different infrastructure or different clouds, because in those different clouds, there are only the worker nodes running. With this, of course, we have a wide range of use cases. No matter if it's for OT and IT, so for running Kubernetes in plants directly at the edge, or of course just multi-cloud or multi-Kubernetes cluster use cases, where you want to create, for example, for your developers, specific use clusters, or for your teams, for your projects in any cloud. That is possible too. But also disaster recovery scenarios can be built with k0smotron. It integrates very well with Cluster API, but before I jump into how it integrates into Cluster API, we'll have a quick look into what is Cluster API. So Cluster API, the subtitle says it all. So simplified declarative infrastructure management. So it can be seen as some kind of alternative to nowadays to Terraform. A lot of discussions about Terraform. or even the OpenTF manifesto. So Cluster API can be an answer. It definitely helps in the first place with cluster sprawl. So if you think about a growing environment, a growing company, and more teams need to use Kubernetes or want to use Kubernetes, you will have the requirement to have several Kubernetes clusters, of course. These Kubernetes clusters can run in different environments, and at some point, of course, the operations and maintenance of those clusters can be very overwhelming, or an operational overhead for your IT staff. That's where Cluster API can help. So Cluster API is running in a central cluster, in a management cluster, and gives you control over all of these clusters. It also does a lot of more things, which we will have a look into. So Cluster API is a sub-project, a Kubernetes sub-project. It's coming out of the community. So it's fully open source. Everyone can contribute. So feel free to contribute too and have a look into that project online too, or on GitHub. So it helps to provision Kubernetes clusters. It helps with for example, with upgrades, with auto scaling or scaling of Kubernetes clusters, and with all of those different day two operations or operations like lifecycle management of a Kubernetes cluster. It uses declarative APIs. So it uses state management. That means you have in the management cluster, you have define a desired state, and this desired state will be applied to your clusters or to the environment. So Cluster API also helps to integrate directly with infrastructure providers. And those infrastructure providers can be OpenStack, vSphere, but also, of course, the big public clouds like Azure or Amazon. So all of those are possible. Or DigitalOcean, Hetzner, when it comes to smaller infrastructure providers, all of those are possible and can be leveraged with Cluster API. So in total, it offers full Kubernetes and infrastructure as code lifecycle management. There's a limitation in Cluster API, which is the default Kubernetes cluster you can create with Cluster API is a Kubeadm cluster. And Kubeadm, of course, can be very complex. That's where k0s and k0smotron can help. But to understand where we integrate with k0s and k0smotron, let's have a look into the abstractions Cluster API adds to Kubernetes. Normally, you have something like pods, you have replica sets and deployments in Kubernetes. So your applications run in pod. If you want to scale them, you have like the replica set, which is created by the deployment. And if you scale that application, it can run in several or many pods. And it's very similar with Cluster API. So you have a machine, you have a machine set, which is very similar to replica set. So you can scale your machines, and you have the machine deployment, which defines how a machine should look like. Next to that, you have two more abstractions, which are essential: cluster and the control plane. We will have a look into all of those in our example and in our demo too. But I think it's very good to have that next to each other. So the default abstractions or the default mechanisms of Kubernetes to understand where Cluster API can help with. So it can do scaling based on the same mechanisms you have in Kubernetes already with pods and deployments. When we now have a look into the different options or where we can integrate with k0smotron and Cluster API 2, is first of all the infrastructure. So the infrastructure can be any infrastructure, as already mentioned, can be OpenStack, Azure, DigitalOcean, but it can also be Tinkerbell, for example. So you can do automatic bare metal provisioning in your data center. So it even can do scaling. Of course, those bare metal hosts or servers need to be available, but it's already possible with Cluster API and Tinkerbell. You have the control plane, which is basically, in our case, the k0smotron control plane. So it is our k0s control plane that is running in a pod and is using, for example, the same mechanisms of Kubernetes to do scaling, or for, let's say, for the backend, you have like volumes, you can use different databases in the background. And we have the machines, and those machines basically can be provisioned by using the k0s worker config template, which is nothing else than a hidden cloud init. So if you create a machine with Cluster API, there's a cloud init script, which is being used to deploy anything that needs to be deployed to that machine. When it comes to the default Cluster API mechanisms with Kubeadm, you need to have a specific image, but with k0s, that's not needed. So you can use Ubuntu, you can use even Red Hat or other OS or Linux operating system with k0s. When we look into the core concepts, and something we will see in the demo too, it is about reconciliation. So the KP controllers or KP controllers have a look into the different custom resource definitions, and will use those custom resource definitions to create or needed resources for a Kubernetes cluster. So when we look back into these three, there is a controller that is handling the infrastructure. So a specific controller that is, for example, talking to OpenStack. There's a controller that is looking into the control plane. And there's a controller that is looking to create the machines in the infrastructure. And those different custom resources can be applied to the Kubernetes API, of course, with kubectl, or you can use Lens to do that. And the KP controller will look into those different CRDs and will create or modify the cluster depending on, of course, the different CRDs or the different YAMLs you've applied to the management cluster. In our case, when we look into k0smotron, it looks like this. So on the left, you have the management cluster. We've already talked about the different controllers. So we have the Cluster API controller that is like orchestrating the different controllers. We have a controller that is talking to the infrastructure provider. And we have the k0smotron controller that is creating control planes. Those control planes, as already mentioned, are nothing else than pods and servers that is exposed, for example, via load balancer. Of course, if you just have, let's say, one load balancer or one external IP address, you can use different other mechanisms like ingress controller, for example, as well, to expose the Kubernetes API or the k0s control plane to the outside. So there needs to be a connection between the infrastructure provider, of course, and the management cluster. But the management cluster can sit anywhere as long as it has some kind of connection to the infrastructure provider, the other way around too. So we need to have the ports available to the k0s control plane. The infrastructure provider in our case can be any Linux. So you can use Ubuntu or Red Hat or Fedora or even immutable infrastructure operating systems if you want. An example of cluster API usage can be, or k0smotron and cluster API can be, that you completely define your infrastructure and how the Kubernetes clusters look like in your own Git repository. That can be GitLab, can be GitHub, can be any other Git that you want to use. And there's tooling that is looking into those different YAML files, into those different resources that needs to be created, like Flux or ArgoCD, that will see those changes or those events in Git and will apply them to the management cluster. And the management cluster has all the controllers, as we already had a look into those different controllers. And we'll create the control planes and the worker nodes in different other in different other infrastructure providers too. Your developers or DevOps or platform engineers can create even, let's say, different stages, different small environments just for testing. So you can even think about adding something like testing to your CI/CD for your application with small Kubernetes control planes, small Kubernetes clusters too, and everything is automated. Even application deployments can be added to Flux or ArgoCD as well. So even that is possible. Now it's demo time. So my little otter friend here is praying for me. So may the demo gods look kindly on me. We will have a look into a small deployment of management cluster running on a single machine. That's again something special about k0s. So you can have single machines with single node clusters where all the different controllers are running in. And we will have Hetzner as a destination, but also this can be like OpenStack or vSphere, so whatever you prefer. And we will create different machines in Hetzner, but we will also create an AWS cluster and cluster in AWS, where you can see what is the benefit of k0smotron. So let's directly dive into some YAML. As you can see here, we have a manifest, which is describing the whole cluster we want to create. So we have a namespace here that says Team Orange. So can be a tenant or a project, can be any other abstraction you would like to see here. So in our case, it's Team Orange, and Orange stands for AWS. So we will have a cluster here that will deploy it in the namespace Team Orange. And we have references to the control plane, mentioned that earlier too, and the infrastructure. In our case, or in this case, it is AWS, so AWS cluster. We can define the control plane, how the control plane looks like. And we can define where this cluster will run, so where the worker nodes will run. So the control plane, as mentioned, is just pods and can be even persistence. There can be very different option for enhanced high availability with k0s. In our case, we'll keep it simple. And then we define where the worker nodes will run. So there's a region, AWS region, we have a VPC here, a subnet, machine deployment. So that's something I already described too. How many replicas? We want to have 3 replicas. We can define different pools, node pools, if you want to. And that's something special again, the k0smotron template. I've mentioned that earlier too. That's our trigger for the cloud init script that will install k0s to those nodes. And the machine template, which defines how the machine will look like. In this case, it's an AWS machine template, which has a specific AMI, just Ubuntu 22. M5 large is the instance types. It has like, I think, 2 cores and 4 gigabytes of RAM. We have the subnet where we want to install it, and we have the SSH key, and of course the security group that is needed. Looks very complex. In Hetzner, for example, it looks definitely easier, but in AWS, of course, you have a lot of different configurations or options that you can apply. And we have this k0smotron template that I've already mentioned here too. So how the cloud init script is being used. And of course, you cannot only specify the version. There are a lot of other configurations you can specify in here. But again, we keep it simple. When we now jump into Lens, which makes it very simple to show you what I'm doing here. You can see we have k0smotron-AWS, a cluster that is running just one node. And there are a couple of controllers already installed in here. These controllers need to be installed, of course, to handle AWS or Hetzner, for example. The steps to reproduce all of the things I'm showing here will be uploaded to GitHub too. So you can have a look into building the same for you, or even if you're interested in contributing back to k0smotron or to Cluster API as well. So we will now do something very simple. We can see there are no clusters in here and no machines in here. So list is empty. And what we will do is just apply one of those YAML files. In our case, this one is now the AWS cluster. So I will just do that. As you can see, we have a cluster in here, control plane, AWS cluster, machine deployment, AWS machine template, and the k0smotron template. So all the things I just showed you. So now we can see there's an AWS cluster, and something that is specific to AWS is patching the infrastructure because it's self-managed, something we need to do with AWS, but it's just one command that we are considering to automate as well in k0smotron. That's something that needs to be done here. We can also see machines, and we can see those are currently pending. I mentioned earlier that k0smotron is creating a pod and a service, and we can see this one here is running in Team Orange in the namespace. And we can see the configuration here. It's very simple. The k0s pod that is running in here, the control plane that is exposed via a service. We can have a look into the service here as well. We can see this one is created 52 seconds ago. We now already have a load balancer created by AWS. So that's all working, and we can see the cluster is up and running and already provisioned. Sometimes the provisioning of the machines can take a couple of minutes. But in my tests earlier today, it took just 5 to 8 minutes. So nothing that takes too long. If you think about manual cluster creation wherever you want to create a cluster. Now, let's do the same for Hetzner. And then we can have a look into the Hetzner tools or the YAML file. As we can see now, there's a second cluster called Hetzner cluster, and it's provisioning. We can also see some machines in pending state here. In AWS, because the management cluster is in AWS, sometimes just the redirect or the allocation of the Kubernetes API can take some seconds. We can also already see it's provisioning. So there are machines that are currently created. So let's just quickly jump back to this one. And we can have a look into Hetzner here. So this one is Team Red. We have Mirantis Labs Hetzner here. We have again the control plane. So what is different now with Hetzner is you have Hetzner cluster, which defines the infrastructure, so where the cluster needs to be installed. We can see it looks a bit different to AWS. That's of course cloud specific, nothing that we can influence, but it's already given. So Cluster API already offers all of that out of the box. But we just need to modify, of course, let's say the SSH key or other small adjustments that we need to do. We have the machine template and the machine deployment. We have the Hetzner machine template where we specify Ubuntu, the type, and the config again. So a bit more simple than AWS. If we now look into, again, into the different clouds, here, for example, I have Hetzner. I can see the no service currently. If I look into AWS, I can already see that there are 3 machines around this Labs AWS cluster, which are currently still initializing, but created just some seconds ago. So 3 minutes ago. So those should be ready in a couple of seconds. And we will see the same for Hetzner Cloud in a second too. And like magic, it just appears and the machine's starting and will be added to the cluster without any manual interaction. When we now look into Lens, we can see that the status changed. And with Lens, of course, it's very simple, but you can use kubectl2 to get access to those clusters. But now I can go into the secrets. And in the secrets, let's look into Team Orange. We can see there's a new kubeconfig here. So a new access file for our Kubernetes cluster, which I can now copy. I go to my clusters in Lens. I add a new cluster based on a kubeconfig file. And I can see there's a new cluster here. I can access that cluster. So this cluster or this kubeconfig file now directly shows me the or goes to the Kubernetes API of the K0s control plane that is running in my management cluster. And now I can see that I have 3 nodes here that are living for 3 minutes. You can see that my default pods that are needed for Kubernetes cluster are running. So I have a full up and running cluster where I can now use Lens, for example, to install Prometheus or other things into that cluster. And it's all magically happening in the background, and everything is up and running within seconds. So just to show how simple it is so this one was AWS, how easy it is with other clusters. I will just add to the hotbar so I can jump into that easily. So let's go back to the k0smotron cluster, so the management cluster. I can do the same for the team red. And I can see there's a kubeconfig file here too. I will just use that kubeconfig file to jump into another cluster. So I will add a new kubeconfig file to the second cluster that I've created with nodes that are running in Hetzner. I will call it k0s child Hetzner. And now I can connect to that cluster, and I will see that I have a new cluster, second cluster, with different nodes. In this time, I have Hetzner nodes running 2 minutes. I have the default pods running in here as well. And I can add it to the hotbar too. So I can now switch between my two clusters very easily here, and all within seconds. So the two clusters were created, when we look into the cluster, one in 6 minutes and the other one 8 minutes. I think that was the 2 minutes I spent to explain what I'm doing. So it's very simple to directly integrate into those infrastructures, create clusters in that infrastructure. And if you think about now what you're paying for in the cloud, it's just the worker nodes. So it's not the control plane, it's just the worker nodes. And the control plane is running in this management cluster, as mentioned here as a pod. For example, for our team red, we have this Hetzner pod that is doing all of the magic, and the Kubernetes API exposing it. And the worker nodes are connecting to that control plane. So let's jump back to our browser. So as you can see, we now have 3 nodes up and running here, and we have 3 instances running here as well. So if you think about now other options like EKS, AKS, so managed offerings, those are all different. In our case, you have one consistent Kubernetes across different clouds. So we've created 2 clusters in the management cluster, 2 control planes, and we've created 2 different or created worker nodes in 2 different environments. This, of course, as mentioned, offers a lot of different use cases and simplifies the management of clusters, especially if you plan to have a lot or many or thousands or dozens. Of course, a lot. Maintenance challenges can be another task. So day 2 operations, if you think about scaling, something I did not cover today. So even auto-scaling of worker nodes is possible, but also updates of the cluster are possible without big interactions, all automated with k0smotron plus Cluster API. So far, that's the content for today. Join me in part 3, where we will have a look into day 2 operations with k0smotron and Cluster API, but we'll show you full cluster lifecycle operations, as mentioned, like scaling and other functionality like upgrades or even backups and restores are possible. So join me in that talk. It already has a date, but it's not publicly available yet. So feel free to just go to mirantis.labs.com, mirantis.com/labs, sorry, to see when this talk will happen. It will be in, I think, now 6 weeks. There will be another different tech talks coming up in the next months. 2 of them, Kubeflow for orchestrating AI workloads in Kubernetes. I will talk about how to run AI workloads in Kubernetes, perhaps in k0smotron and k0s, who knows? And my colleague Peter will introduce you to Ceph and Rook, so automated Kubernetes storage orchestration. If you have interest in installing, as mentioned, feel free to go to github.com, Mirantis Labs. Yes, we will share the slides too. That will be in the GitHub repository. So you will find everything there too for the part 1 too. But I will include what I've did in part 1, in part 2 too, because you need to have the management cluster up and running too. As mentioned, it can be installed in any environment. So feel free to try it yourself, test it, leave us comments, feedback, or reach out to me directly. I can definitely share some experience or help you to get a cluster up and running. Thank you too. And if there's no further question, have a nice day, morning, evening, wherever you are. And thank you for your patience.